Hi people, how are we doing today? I hope we are having fun and staying safe. This is the 8th video in the 100 days of code series. Now going forward, this video will not be in a particular order. It would be as a result of questions I'm getting. So if you have any question about 100 days of code or getting started with programming, please drop them in the comment section below and I'll try as much as possible to get to them. Now I got a question from one of my viewers and she asked me what the difference is between storage and a database. Now, when you run your programs, ideally these things run somewhere. Even though all you do is click on the stuff, you run Visual Studio, you run VS Code, you run your favorite coding environment, and these things run somewhere. It actually runs on a storage, but this storage is temporary because when you close the application, there's nowhere to find it until you launch it again. Then you can try to go and load the file up on your system. Now when you think about that, there are two kinds of storage. There's one that is permanent, which is where you get your source code, and there's one that is temporary, which is loaded up to your system once you start running the application. So sometimes when you see application requirements, it has minimum system requirements. These are the basic things the system needs to have. Now I said earlier on that there are two kinds of storage. There's a temporary storage, and then there is a permanent storage. Temporary, pardon my spelling, and permanent storage. Now this kind of storage, I will explain them now. Now the temporary storage are the storage that basically is employed when you run your applications. For example, when you launch your code editor, the time it takes to run, say for example you run it for 5 minutes, what it means is that this application is loaded up onto your temporary storage for 5 minutes, and the kind of storage that fall in this category will be your RAM. So you have different sizes of them: 512 kilobytes, 200 megabytes, 1 gigabyte, 4 gigabytes, and 2 gigabytes. Now the more your RAM, the more the number of applications you can run on the system. That device, sometimes if you run applications that start consuming your RAM size, your system starts slowing down. It's trying to, dead some applications and make some work fine. So this is a kind of temporary storage. These are storage for the instances of your application. So you launch your video player, you launch Instagram, you launch Twitter. These apps are loaded onto your RAM from your permanent storage. So let me talk a little bit about the order in which applications actually run. Now, you have your permanent storage. I'll talk a little bit about permanent storage in a bit now. So you have permanent storage, and your application is loaded. An example of permanent storage would be your hard drive, your flash drives, your SSDs and all that. So you load the application from here, then it gets loaded up onto your RAM. So this is a temporary storage, and then the application runs. If you need to store anything, maybe you need to save a file, you need to do anything, the application takes that and stores it back into the permanent storage where you can retrieve it in the future. Now, kinds of permanent storage. When you think of permanent storage, you want to think of things like your hard drive. You want to think of things like your databases, because they are more permanent. You want to think of things like your files. Yes, text files, JSON file, picture files, video files. These are more permanent storage. Now, your files, you can store information in files. For example, you can store some text file to contain user information. This is typically stored somewhere on your hard drive or a network drive somewhere. So, database as one entity, which is the sort of bone of confusion for the person who asked this question, falls under permanent storage. So database is a kind of storage, the hard drive is a kind of storage, your flash drive is a kind of storage. Now, when the application runs, the system loads the file from these many storage locations where this might have been stored. and then runs it. Now, the way it reads the information is now different. If you're reading something from a database, for instance, if you're reading something from a database, this information is loaded up directly into your RAM. It doesn't go to your permanent storage. No. When it's loaded up onto your RAM, which is where your application runs, if you now need to save that to the system, it goes back to the system from the RAM. So what we call something from your database could be an API, could be your app, could be anything. And this information is loaded up directly onto your RAM. So that's why sometimes when you run some apps on your systems, it takes some time before it gets itself, because it's retrieving that data from a remote source and then trying to load it up to your system. So you have to just wait a little bit. Now, depending on the strength of your system, on the strength of your PC or if your phone or anything you're using to run this app, the speed might differ. That's why sometimes it will take some people with more powerful computers a shorter time to run some applications compared to people who are using computers with lesser power. Now, and I hope this has been a sort of eye-opener and an answer to the difference between a database and a storage. So the answer is database is a kind of storage. And we have two types of storage: temporary storage and permanent storage. Temporary storage, you'll have your RAM. Permanent storage, a database is one of them. Your pen drives, your memory card, your hard drives would fall under permanent storage. And I hope that has answered your question. If you like this video, of course, please give it a thumbs up and remember to subscribe so you will get notifications when I post new videos on this channel. Till I come your way again with another video on 100 days of code, that's when I have a question or an idea to share with you. Please go ahead and stay safe and have fun and enjoy coding. Peace.